Common and natural logarithms. Our objective for this video, we want to identify and solve problems involving common, base 10, and natural, base E, logarithms. I've mentioned in previous videos that these are the two most used or the two most common logarithms. The base 10 logarithm, which they call the common logarithm, and the base E logarithm, which they call the natural logarithm, and we'll have that written down here for you in just a few pieces here. So what do we know? We know what a logarithmic function is. It's any function of the form y equals log base b of x, the argument, where the base is positive but not equal to 1, and x, the argument piece, is also positive. Okay, as I've mentioned here and there, okay, the two most popular bases are 1, base 10, which we'll talk about here, and 2, base E, which we will speak to. Is my paper straight? I think it is, which we will speak to down here. So base 10. Base 10 is also called the common logarithm. If somebody is asking you to find the log, they're asking you to find the common log more often than not. On a calculator, it's the log button. I've shown this before, so on the calculator, along the left side here, on my calculator, there's a log button right here. It's kind of a shortcut button. It just says log, and that means it's a log base 10. So if I go into here, let me get out of my graphing, and I say, find the log base 10 or find the log of, I would do log of, let's say 100. Notice there's no base here. There is a base right here because I used the other log, but they gave me a base choice. But the 10 is assumed as a base in here, okay? And it's simply, so on a calculator, it's the log button. It's how many times do we need to use 10 in a multiplication to get our desired number. So log of 1,000 is the same thing as log base 10 of 1,000. You can use the log key, which is I just pointed out, or you can use that log variable base key and put a 10 in there. In either case, the answer is 3, because 10 multiplied 3 times by itself gives you 1,000. Okay, the base E log. E is Euler's number. It came out of a study of compounding with money, but it's also found in nature in a variety of places. It is called the natural logarithm. So base 10 is called the common. Base E is called the natural. On a calculator, it's the natural log, or LN. I guess that means log natural button. Let's go to here. And you can see again along the left side, here is the LN button right here. It's a shortcut to do the natural log of something. So when I enter, let me first get out of this one. When I enter natural log, I'm thinking this is the log with the base of E, but it doesn't say log, it says ln. And because it says ln, you don't need a base because the base is assumed to be E in this case. Okay? All right, so in the calculator, it's the natural log button. It is how many times we need to use E in a multiplication to get our desired number. So what is the natural log of 7.389? Okay, that's the same thing as the log base E. I could put it in my calculator as log with a variable base of E of 7.389, and the answer is approximately 2. E squared, remember we did this little loop here, E squared is approximately 7.389. Okay, remember log outputs an exponent. So let's take a look at a couple of examples. We'll just kind of use the log, the common log, and the base and the natural log. Example 1, the percentage of adult height attained by a boy who is X years old can be modeled by a logarithmic function, and here it is. 29 plus 48.8 times the log of x plus 1. X represents the boy's age, which is from 10 to 15, and f of x represents the percentage of his adult height. Okay, the question, approximately what percent of his adult height has a boy attained at age 8? So it's 8 years old, so x is 8. So I'm going to do my f of x is equal to 29 plus 48.8 times the common log, because there's no base and it says log. If you want to put a 10 in there, because it'll help you to see it, you can. But when we just see the log by itself with no base listed, we know it's base 10 of of 8 plus 1. Okay? So let's put it in here. And I'm going to use that common log button, clear this one out. So 29 plus 48.8. And again, I can go down here and I can select the log button because it's base 10. It doesn't, as I repeat here, it doesn't show a base 10, but because it's the common log, we assume it. And then we're going to put in 8 plus 1, and we're going to press enter. And it looks like it's about 75.6 to the nearest tenth. So it's approximately 75.6% of his adult height. So this formula, this function gave us what percent of his adult height has he reached by age 8. Well, by age 8, a boy between 10 and 15. The boy's age, X represents, I'm not sure why the 8 is here, and it's not between those two. Nonetheless, we're fine. Looks like about 76% of his height has been attained by age 8. So there's a common log. Okay, give me a moment. Let me get my other page to do a natural log example. Make use of that natural log button. All right. Okay, when the outside air temperature is between 72 degrees and 96 degrees Fahrenheit, the temperature increase in an enclosed vehicle can be modeled by the function f of x equals 13.4 times the natural log of x minus 11.6. X represents the number of minutes that have passed. You probably see this, we certainly see this in the summertime in the news when dogs, or unfortunately when dogs or babies are left in the car with the windows up and the temperature increases very fast. We want to use this function to find out the temperature increase to the nearest degree after only 50 minutes, so less than an hour. How much does the temperature increase? Okay, so this gives you a sense of what happens when in a car, enclosed vehicle, how fast the temperature can increase. So after 50 minutes, so f of 50 is equal to 13.4 times the natural log. And if you want, if it helps you, if you want to write a little e down here, you can. But the natural log is the log base e of 50 minus 11.6. Okay, so let's see here. The natural log. So I'll go into here and I have, I'm going to do 13.4 times the natural log. Well, that is, let me go to here. My calculator, that button is down here. Okay, a special button for the natural log. So I'm going to press that button and get the natural log. Again, the base is not shown, but because we have a natural log, the letters, we know the base is the letter E. We'll put 50 and then we'll subtract 11.6. And the temperature increase is 41 degrees to the nearest degree. So it's approximately a 41 degree increase in temperature. So this gives you an idea. If you're sitting at 80 degrees, for example, and you enclose your car and leave for 50 minutes, After 50 minutes has gone by, the temperature will have increased by 41 degrees. It will now be 121 degrees in that car. And that's how you can see that bad things happen when live animals or people are left in a car. So there you have it. We've worked with the two most common, the natural log and the common log, which is the log base 10.